Okay, guys, so today we are simplifying radicals. So the first thing that we need to talk about are the opposite of radicals. So these are the opposite of radicals. These are your exponents. So for your perfect squares, 1 squared is 1, 2 squared is 2, 3 squared is 4. You should know the squareds, most of them by heart. And then you have the cubes, so 1 cubed, 2 cubed, 3 cubed, 27. These ones will use a lot more than the larger ones, so I only went up to 10 cubed. And then we have, oh, we're kind of tilty. Oh, that's much better. Okay, then we have to the 4th power, and then the 5th power. And the reason that I'm showing you this is because today we're going to do the opposite. So we're going to figure out what the 5th root of 3125 is. Well, the 5th root of 3125 is 5. So we're going to go backwards. We're going to have these numbers, these larger numbers, and then we're trying to figure out what the root is, what the smaller number is. Okay, so that's our goal. We are simplifying radicals. The best way to do this is by making cute little fraction trees or factor trees, sorry, just like we did before. So for example, let's get a pen. 72, so I'm going to think of numbers that multiply to get 72. Well, I want to lean towards my perfect squares, so when I get a perfect square, I can kind of stop. Because if you don't see a number on the shelf, it's a 2. But we'll get there. Okay, so 72 breaks up into 2 and 36. Ooh, notice this guy's a perfect square. So that's really important. You could keep going if you wanted to. 36 breaks up into 6 and 6, which is 3 and 2 and 3 and 2. Okay, so this is how it works. Whatever number sits on your shelf, however many are on the inside that are of the same number, they get to come outside. Which sounds really awful, but let me show you. Okay, so we're doing square root of 72. And when you don't see a number on the shelf, there is a 2. So I want all of my pairs. All right, so what I'm saying is if I were to break this down into just these simple factors, I have 2 times 3 times 2 times 3 times 2. And when I multiply all of those together, then I get 72. When I have a square root, I'm looking for pairs of the same number. So, for example, I have a pair of 2's. I've got a 2 and a 2. And I have a pair of 3's. What other thing doesn't have a pair, or however many you're looking for, that stays underneath the root. So we're going to have this lone little 2 underneath our root because these two numbers have a pair and these two numbers have a pair. When you put the number in front, because since they're pairs, a number is going to go in the front. When you put the number in front, you're going to take one of the pair, or one of the 3, or one of the 4. So of your pair, they all cancel except for 1, and that goes in front. Of the pair, they all cancel except for 1, and that goes in the front. And they're multiplying. Well, 2 times 3 is 6. And we keep our root 2. So the square root of 72 can be reduced or simplified to be 6 root 2. Now, remember back at the beginning, I said we were looking for roots. So another way to do this problem is to split it. Well, we found a root, a perfect square, 2 times 36. Okay, so instead of writing it like this, there's a second option. So you can write the square root of 2, because that guy came from here, times the square root of 36. So the square root of 72 is the square root of 2 times the square root of 36, because 2 times 36 is 72. Well, I know the square root of 36, it's 6. So I can't figure out the square root of 2 without it being in a decimal, so I'm going to leave that guy there. And then times 6, because the square root of 36 is a perfect square, so that would make 6. We don't write it like this. It looks kind of funny. The number goes in the front of your root, of your radical sign. So we would rewrite this problem as 6 root 2, which is what we got when we did it the other way. So either method is totally fine. I'm going to do both methods just so that you can really see what's happening. Okay, number 4. So 4, we've got 750. Well, if I divide that by 6, I get 125. Now this is an important number. So if we look on our shelf, we've got a 3. So I want 3, not 2. Like here we wanted 2 of a kind. Now we want 3 of a kind, which means 3 of the same thing. So if we look at our cute little numbers that we made, see how 125 is an important number because it has a cube. So I know that the cube root of 125 will be 5 because 5 times 5 times 5, 3 5s multiply to get 125. So that's why that list was important at the beginning. Okay, so we can rewrite this if you want to. We know 125 is the same thing as 5 times 5 times 5. So we have two options. Again, I'm going to go through both of them. So the first option, got to keep that 3 on that shelf, is 6 times the 3, 125. So you can write it like this. So the cube root of 125 is 5. We still have our 6 and our 3. You have to keep your 3 on your shelf. And then times 5. And then I'm going to rearrange this. So this will be, 5 root 3 and then 6. Or, sorry, you could do the cube root. Well, we know it's 6. And then 5 times 5 times 5. And you could have broken this down differently, but you would have gotten that, the 5 times 5 times 5. Okay, so cube roots, I'm looking for 3 numbers that match. Well, I have that with my 5s. So one of them goes in front, one of the 3, because I have a 3 on my shelf. So one of the 3 goes in front, and the others go away. So this would really be 5 root 6 with a 3 on the shelf. Okay, so let's see. Let me do another example. I want to look at which ones I made you do. Let's look at 13. Yeah, 13. Okay, I want a 5th root of 160 and then the r to the 8th power. Okay, so I want 5 numbers on the inside that match. So that's what we're going to do. Okay, so we're going to start with a cute little factor tree because I love factor trees. So 160. And then I know if I divide 160, it's got ends in a 0. So I'm going to try dividing it by 5. And then I got 32. Well, I'm going to come over to my cute little list. And since I have a 5 on my shelf, I'm looking for anything with the exponent of 5. So that's this group. And I want to match 32. Oh, snap. Okay, 2 to the 5th power is 32. So this is my important number. So instead of 32, I'm going to have 1, 2, 3, 4, 5. And then, so all 5 of these times 5 is 160. Okay, now with the r's, remember the exponent is a counter and it's telling you how many. So we don't really have to make a factor tree. You can just know that there's 1, 2, 3, 4, 5, 6, 7, 8. Or you could use subtraction. It's totally fine if you understand what I'm saying. If you don't, that's fine. Okay, this number in the front, he's just going to hang out, -2. I'm going to show you the second way first, like we did over here, because I think maybe that's easier to grasp onto. Okay, so I draw my little root sign. I put my 5 on my shelf because it has to stay there. And then I know that I have 1, 2, 3, 4, 5 2s. And then I can't forget my 5, so times 5. And then I also have these 8 r's. I kind of ran out of room because I didn't plan that very well. Looking for paper. I don't see any paper. Oh, heavens. Oh, that'll work. Okay, so we'll just keep drawing it on. I'm just going to cover up what we did. Okay, 5 times 1, 2, 3, 4, 5, 6, 7, 8. Okay, so all of this is under my root sign right now. All right, so now what we're going to do is we're going to find 5. Okay, so we have 5 2s right here. That 5 doesn't have 5 5s, so we leave that alone. And then I have 1, 2, 3, 4, 5 R's. Okay, remember, one of them comes out, the others go away. And they come out to multiply, so that's the operation. So -2, we already had that in front, the leading coefficient. Then we're going to multiply it by 1 of the 5 here, and the rest go away. And then we're going to multiply it by 1 of our next 5, and then the rest go away. And then we don't have any more 5s, so then I have a 5 here, and then, oops, oh no, I crossed these 3 out. 1, 2, 3. These guys should be underneath. Sorry, I got a little aggressive. Okay, so only these 4 canceled. So those 4 canceled, which means I have 3 R's left underneath. And again, if you subtract, 8 minus 5 is 3, so we're going to keep 3 underneath it. That's all you have to do for the variables. Okay, we're almost done. Then we just multiply these guys together that are out in front. So -2 times +2, I think I'm going to move my answer, is -4. I still have my R, and then I have my 5th root of 5R to the 3rd. And this is simplified, reduced. We'll do another one. Okay, 11 looks tricky. And I know that you're like, oh, you can't do the square root of a negative number. Well, you can, but not today. But I'm not doing the square root. I'm doing the cube root. So I'm going to go back to my cute little notebook. All right, so cubes. So I'm looking for 1, 8, 27, 64. Oh, 8 goes into 16. I know that if I have 16 and I divide it by 2, I get a -8. Now you want to leave this negative attached to the number that is cubed, okay? And the reason why is because we might have a lot of extra junk left over. But when we pick out one person to come off, we're going to take that little negative with us. So remember, when you get a positive number, it's a negative times a negative or a positive times a positive. But to get a negative number, you need an odd man out. So you need a positive and a negative, or 2 positives and a negative, or 3 negatives. You have to have an odd man out. And that always attaches to whatever comes out of your radical, your root. So make sure if it's a cube root or a 5th root or a 7th root, those are all odd, so you can take out a negative with you. Okay, so what I'm just trying to say is that instead of having a -8 here, we're going to split that into 3, because I know that -2 times -2 times -2 is -8. So that's how we're going to do that one. Okay, so I'm just going to rewrite this, keep my little -8 on the outside and my 3 on my shelf. And then instead of -16, I'm going to have 2 times those guys. So 2 times -2, -2, -2. And then I have 7 ends. 1, 2, 3, 4, 5, 6, 7. I didn't put all my multiply signs there, but I know you know those are all multiplying. Okay, so I'm looking for groups of 3. So I've got my first group of 3, I've got my second group of 3, and I have another group of 3. Everything that's not in a group of 3 stays. So underneath my root sign, I'm going to have my 2 and an n. Of the groups of 3, remember 1 comes out, so one of these is going to come out, one of these is going to come out, and one of these is going to come out, and the rest, oops, dang it, I keep doing that. The rest get canceled. So in front, we have -8 times -2 times n times n. Okay, and then we simplify and finish this problem by actually doing this multiplication in front. So -8 times -2 is +16. N times n is n squared. And then we have a cube root, so put your 3 on the shelf, of 2n, because that's what's left over. Okay, let's do one more, just to be sure. We're going to look at number 10. Okay, so on number 10, I'm going to split up my 54 into something. But I have a 3 on my shelf, so it's going to be a cube root. So I'm going to look at my numbers. Well, I have 8, 27, 64. Well, 64 is a little too big. So I want to try to split my 54 into either a 27, an 8, or a 1. But not necessarily a 1, because that's still not going to make it very pretty. So those are the numbers that we want to split it into. Okay, so let's do 27, because 54 divided by 2 is 27. Just want to make sure. Yeah, okay, so 54 divided by 2 is 27. Now remember, 54 is negative, so I'm going to split my 27 into 3 parts, just like my number said here. So 3 parts, 3 times 3 times 3 is 27. But we want it to be negative, so it's going to be -3 and -3 and -3. So in my calculator, let me just show you, just so you get a full grasp of what's going on. -3 times -3 times -3 times 2. So those are all my roots. These guys are my roots to my factor tree. Okay? So all those numbers multiplied together will give me -54, which is what I have on the inside here. Okay, great. So I'm going to keep my -3 out in front. Nothing happens. My 3 goes on my shelf. And my -54, we're going to split into -3 times -3 times -3 and a 2. Okay, so I want groups of 3. So I have one group of 3 and then nothing else. I'm going to keep my -3 out in front. One of these is going to join, the rest go away. So it's -3, always multiply, times -3. Then I have my shelf with my 3 on it, and my 2 is left over. So this simplifies to be -3 times -3 is 9, the cube root of 2. If you wanted to do this a different way, you could stop here. So a different way would be -3 times the cube root of -27 times the cube root of 2, because that's what's left over. -27 times 2 is -54. I know that the cube root of -27 is -3. Keep my little negative here. That guy goes to -3. And I am going to leave this guy alone because 2 doesn't have a cube root. -3 times -3 is 9 cube root of 2. So again, I got the same answer. It's just a different thought process if you're looking for perfect cubes or perfect squares or perfect fourths or whatever you want to call them. And or if you want to just look for groups of whatever numbers are on your shelf. All right, let me know if you have any questions. Have a wonderful day, guys. Bye.